arithmetic sequences. Next lesson will be geometric sequences, so make sure that you pay attention to the difference between the two. For an arithmetic sequence, we will have a common difference, and when we get to geometric sequences, we will have a common ratio. So an arithmetic sequence is a sequence that has a difference between consecutive terms that's the same, which means we have a common difference. So starting with example 1, we want to find the common difference of this sequence. So we have 5, 8, 11, 14, and 17. And then if you were to continue on, that's what the dot 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 means. And then you have 3n minus 2. This right here is just the equation that represents these beginning terms, or the first, second, third, fourth, fifth term of the sequence. So I want to figure out what the common difference would be. And this one's pretty obvious that you're going up by 3, up by 3, and up by 3. So between 5 and 8, you're going up by 3. Between 8 and 11, you're going up by 3. And same thing here, and same thing here. But if it's not that obvious, then you would take like the second term, which is 8, and you would subtract the first term, which is 5, and get 3, and just make sure that that is consistent all the way through. But to answer the question, the common difference, D, is 3. So let's do the same thing on the next two. The common difference here, like I said, this was pretty obvious what's going on here, but let's take the second term, 5, subtract the first term, which is 9, and 5 minus 9 is negative 4. And you can see that this is going down by 4. This is going down by 4, negative 4. Oops, negative 4. This is going down by 4, and same thing there. So your common difference is negative 4. And on the last one here, if I take my second term, 7 6, and subtract 1, that leaves me with 1/6. So to go from 1 to 7 6, I'm going up by 1/6. And you will have to use common denominators to add here and reduce, but these fractions are going up by 1/6 all the way across. So your common difference here is 1/6. Now I'm going to go back to the first example real quick, and some of y'all may have noticed this, but your common difference is right here in the equation. Your common difference was 3, and look where your 3 is right here in the equation. It's right next to n. Look at example 2. Your common difference was negative 4. Look where negative 4 is, right next to the n. And then right here on this one, you have n plus 5 divided by 6. Well, here's your 1/6, your 1n divided by 6. So your common difference, it's right there in the equation if you'll just look for it. We have a couple of different equations that we can use to work with arithmetic sequences. We have this a sub n equals dn plus c, and I'm going to tell you what each part of these equations mean. The d we just looked at means the common difference. So let's write d right here as the difference. And the c in the equation is the first term. This is the first term minus the difference. Now, to be honest with you, we're probably not going to use that equation too much because you're really limited as to what information you have and what you can do with this equation. So I'm going to suggest that you use this one for basically everything. And let's talk about what the different pieces of this equation mean. D, I think y'all can probably tell me what the D is on this equation. D is going to be your difference. A sub 1 is your first term in your sequence. And n is going to be your term number. Like if it's the 8th term, you would plug in an 8 right there. So this would be your term number. Let me try that again. Term number. So A1 is the first term, N is the term number, and D is the difference. So from here on out, for all these problems that I'm going to work out, I'm going to refer back to this equation right here. So let's try number 2. Find a formula or an equation for the nth term. That just means the general equation. You're just going to write an equation for the arithmetic sequence whose common difference is 5. So that means D is 5. And the first term is -1. So A sub 1 is -1. So I want to write a formula or an equation to represent a difference of 5 and the first term of -1. So let's use this little formula here. And I would get A sub n, so any term number equals A1, which is my first term, plus n would be any term number minus 1 times my difference, which is 5. I've just plugged in here. A sub 1 equals any term number n minus 1 times my difference. Now, I just want to simplify this, so I'm going to distribute backwards. This is -1 plus 5n minus 5. Combine your numbers. We'll come over here where you can see it a little bit better. So an equals 5n, and then -5 and -1 is -6. So there's your formula or your equation with a common difference of 5 and a first term of -1. For example 3, we're going to write the first 5 terms of the sequence. Let's see, the 8th term of a sequence is 25, so let's write that down. Let's write down A8. I'm going to write this over here. The 8th term is 25, and the 12th term is 41. And we want to write the first 5 terms of the sequence. So I want to write A1, A2, A3, A4, A5. I want to write A1, 2, 3, 4, and 5. And I want to do this using equations. I want to write the general equation, and I want to go back and figure out the first 5 terms. So some of y'all are going to try some sneaky ways around this, and I'm not saying that this may necessarily be the easiest way, but you need to get some practice using this equation and get some practice writing these equations. So let's follow along with me here. The 8th term is 25 and the 12th term is 41. The first thing we need to do is we need to find D. We need to find what the common difference is. Well, between 8 and 12, right? Between 8 and 12, we have 4 terms. Well, we have A8, and then we're going to have A9, A10, A11. We're going to have to count, not 4 terms, we're going to have to count the difference 4 times. We're going to have to go from the 8th term to the 9th, to the 10th, to the 11th, and to the 12th. So we're going to have to do the difference 4 times to go from the 8th to the 12th. We're going to have to add the difference 4 times. So I'm going to come over here, and to get to the 12th term, I'm going to have to start at the 8th term, and I'm going to have to add the difference 4 times. So I know that the 12th term is 41. I know that my 8th term is 25, and to get from 25 to 41, I've got to add the difference 4 times. So find out what D is. Subtract 25, you get 16. Divide by 4, and 4 is D. Okay, so that's the first thing that we have to do is find D. So the second thing we need to do is we need to find what A1 is. So to do that, we can either use A12 or A8. Okay, we can use either one of these terms that we were given, and it doesn't matter, either one. And we're going to go back, and we're going to use this equation, and we're going to plug in what we know, and we're going to figure out what A1 is. But this will be missing. We don't know what A1 is. So let's figure out what we know. I'm going to use A8. Okay, that's just the one I'm going to choose to use. You don't have to use A8. You can use any term number you want, but I'm going to, or you could have used A12, but I'm going to use A8. So term 8 is 25. So I'm going to say, here's how I'm going to set it up. I'm going to say A8 is going to equal A1 plus A8 would be the 8th term minus 1 times the difference. So that's what my equation is going to look like. A8 is 25. I don't know the first term. I know that 8 minus 1 is 7 times D. Oh, let's see, we know that D is 4, so I can plug that in. Hold on. Sorry about that. Okay, so I know that D is 4. So 7 times 4 is 28. Go ahead and subtract 28 from 25, so that's negative 3 equals A1. So if negative 3 is A1, negative 3 is A1, it doesn't actually ask me to write the formula, but I am going to go ahead and practice this since we don't have a lot of examples here. Let's go ahead and write the formula. Okay, let's go ahead and practice and write the formula. So AN equals, let's go back over here and look at your formula. A1, which is negative 3, plus n minus 1 times d. Distribute backwards, so it's negative 3 plus 4n minus 4. So an equals 4n minus 7. Now, do you really need to plug in the formula? Plug in 1, 2, 3, 4, and 5 right here to figure out the first 5 terms? No, because negative 3 is the first term, and if your difference is 4, all you're going to do is add 4, add 4, add 4, and add 4. Now, just in case this is getting cut off by the screen, I'm going to write A5 over here because sometimes that gets cut off on the bottom of the screen. So A5 is 13. But what if I wanted to know, say, the 100th term? You know, you wouldn't want to count down to that, so in that case, you would want the equation so that you could plug 100 in for n to figure out the 100th term. That's where having the equation or having the formula is important or is useful. But to answer the question, we were supposed to find the first 5 terms, so there we go. We just had to do all this work to get there. All right, number 4 asks us to find the 10th term. So I'm looking for A10 of the sequence that begins with 8 and 20. So if it begins with 8 and 20, that means that A1 is 8 and A2 is 20. So if that's the case, the difference is 12. You just find the difference between those two. So let's write the general equation. So AN equals your first term plus n minus 1 times your difference. Distribute backwards. 8 plus 12n minus 12. Combine those numbers. So AN equals 12n minus 4. All right, so this is your general equation, but I want to know the 10th term. So I can come down here and I can find the 10th term, which means I plug a 10 in for n right here. So 12 times 10 minus 4. So the 10th term would be 116. Okay, and when it comes to finding the sum of a finite arithmetic sequence, finite just means that it starts and stops. You have a formula and it's really easy. S of n means the sum of however many term numbers you have. N means the number of terms, so let's write that up here. N is however many number of terms that you're adding together, over 2 or divided by 2. A1 is the first term in your sequence, and AN is going to be the last term in your sequence. So that's how you do the sum. Now, in this first example, if you're going to find the sum of this sequence, all you would really have to do is add all these up. Yes, I understand that. Just 40 plus 37 plus 34, add them all up, that's no problem. But what if you had like 500 numbers to add up? Would you really want to sit there and add them all up in the calculator? Probably not. So if you have a calculator handy, add all these up and see what you get. And then let's try this little formula and see if you get the same thing, which you should. If you count, there are 7 numbers here. So we're going to find the sum of these 7 numbers. To find the sum of those 7 numbers, we're going to have 7 divided by 2 times the first number plus the last number. And calculate that. Do 40 plus 22 times 7 halves, and you should get 217. And that is the same answer you would get if you added all of those up. Same thing with B. If you want to sit there on your calculator and if you want to add 1 to 35, if you want to do 1 plus 2 plus 3 plus 4 plus 5 all the way up to 35 in your calculator, go for it. Chances are you're going to mess up and miss hitting a button, or it's going to take you a while. Or we can do the sum formula. We can do the sum of the first 35 numbers. So that would be 35 divided by 2 times the first number plus the last number. So 1 plus 35 is 36 times 35 divided by 2, and that is 630. Okay, last one. Same thing, 1 plus 57. Sit there and punch away on your calculator if you want. And I know some of you will do it just to see if you come up with the right answer or come up with the same answer. But man, that will take a long time, especially if we get some big, long sequences there. So let's do S of 57. The sum of 57 equals 57 divided by 2 times 1 plus 57. 57 plus 1 times 57 divided by 2 is 1653. On example 6, determine the seating capacity of an auditorium with 30 rows of seats. If there are 20 seats in the first row, 22 in the second, 24 in the third, and so on. Now guys, please use the formulas for this. Some of you will sit there on a quiz or a test and you will literally try drawing out 30 rows of seats and draw these little seats and try to draw 30 rows and count them. And you will be there forever and you will probably miscount and mess up. Do not do that. Do not draw and list them out. Just use the formulas. It's so much easier. Okay, so we're going to have 30 rows. That means our N is going to be 30 because we're going to have 30 rows of seats. There's 20 in the first row, so that means A1 is 20. And there's 22 in the second, 24 in the third. Excuse me. That means our difference is going to be 2. And the reason I'm trying to figure out what my difference is going to be is because in my formula, I'm going to find the sum of my first 30 rows, or my 30 rows. And in order to do that, I need 30 divided by 2 times my first row plus, and right here, I need my last row. And I don't know how many are in the last row yet, so I need to figure out how many are in the last row. So I need to calculate that. So that's what I need to do right now. And let's write the general equation. Let's do AN equals A1, which is 20, plus N minus 1 times my difference. Distribute backwards. 20 plus 2n minus 2. So, oops. Hold on. AN equals 2n plus 18. That's an 8. Okay, so that's my general equation. I need to know how many seats are in row 30. So A30 equals 2 times 30 plus 18, which is 78. So now I can take 78, put it back right here, and I can finish this out. So 20 plus 78 multiplied by 30 divided by 2, which is 15, and that means in the whole 30 rows of seats there are 1,470 seats in the auditorium. And for the last example, we're going to consider a job offer with a starting salary of $32,500. The starting salary, A1, $32,500, and an annual raise of $2,500. An annual raise, that means that's my difference, $2,500. Determine the total compensation. Total compensation, that means your sum from the company through 6 full years of employment. So I want to find out how much I made total, adding it all up for 6 years. So the last thing I'm going to do is the sum of 6 years of employment equals 6 divided by 2 times my first year's salary, $32,500, plus this right here needs to be my 6th year's salary. So I need to figure out my 6th year's salary. All right, so let's do that. Your 6th year's salary is going to be your first year's salary, A1, plus 6 minus 1 times your difference. And 6 minus 1 is 5 times 2,500 plus what you started with. So in year 6, you're making 45,000. So I can take that, come put it over here for your 6th year. That's $45,000. And now you can finish your formula. You can add these, multiply by 6 divided by 2, which is 3. So the sum of the 6 years would be $232,500. And like I said earlier, there's going to be some of you who are going to try to get away with not using these formulas. Okay, and I know 6 years isn't very long, and some of y'all are going to try to do this, just finding the 6 years and adding them up. But what if it was something like 20 years? It's going to take you a long time to do that. Just please don't avoid the formulas and just practice with them. They're not that difficult. And that is it for section 9.2.